Welcome to this explainer. Today, we're diving into a pretty incredible story. We're looking at how a nation literally born on barren sand managed to engineer its way into becoming a global water superpower. It's this massive tale of survival, cutting-edge science, and sheer willpower that completely reshaped an entire landscape.
Just try to imagine building a brand new nation and, actually surviving in a place where a staggering 60% of your land is just an unyielding, rainless desert. That was the harsh reality of the Negev. We're talking about an expanse of heat and sand where ancient civilizations literally fought wars over single drops of water.
For centuries, a lack of water here meant immense human struggle. Every single container of water you needed required back-breaking labor. It was a constant, daily battle against nature. In fact, the environment was so severe that the British initially declared the land practically impossible to populate, insisting there simply wasn't enough water to ever grow enough food. But they did it. And today we're going to track exactly how this massive problem was solved across 5 distinct eras. First, the impossible desert. Second, moving rivers over mountains. Third, the magic of leaky pipes. Fourth, drinking the sea. And finally, a global blueprint.
So let's jump right into the first era, the impossible desert, starting with 1948 and the looming water crisis.
When the state was established in 1948, hundreds of thousands of immigrants poured in. The population absolutely exploded, tripling in practically no time. And this created a terrifying mathematical problem. You see, rain mostly fell up north, near the Sea of Galilee, but the vast majority of the land down south was a parched desert. The math for basic human survival just didn't add up.
Which brings us to our second era, moving rivers over mountains, or what I like to call the brute force era.
Their very first solution to this impossible geography was pure, audacious brute force, the creation of the national water carrier. And the physics involved here are just staggering. First, they captured water 209 meters below sea level at the Sea of Galilee. Then they used these massive 30,000 horsepower pumps at the Superior Station to literally lift it up. From there, the water was pushed through heavy-duty concrete pipes built to withstand crushing pressure, literally the equivalent of diving hundreds of meters underwater. They even used these giant U-shaped pipes that relied on gravity and momentum to cross deep valleys, eventually delivering millions of cubic meters of water entirely uphill to the parched Negev.
But, as you might expect, solving a massive drought created a geopolitical crisis. In 1964, right as the carrier was about to start operating, the Arab League summit convened. They proposed a counterplan to divert 35% of the Jordan River's headwaters, specifically the Banias and Hesbani rivers in Syria, away from the Sea of Galilee. They even created a unified Arab command to protect this diversion project. This really proved that water infrastructure wasn't just about farming anymore. It was undeniably a critical matter of national security.
Okay, moving on to era number 3, the magic of leaky pipes, also known as the efficiency era.
So as that massive water carrier pumped away, it eventually threatened to drain the Sea of Galilee dangerously low. They desperately needed a micro-solution to save the macro system. And the breakthrough? It came from a surprisingly simple observation. An engineer named Simca Blas noticed a massive tree thriving in the desert, seemingly without any water. When he dug down, he found that a single tiny leaky pipe coupling was creating this expanding underground area of moisture that reached perfectly to the roots. Seeing these tiny drops cause the growth of a giant tree sparked an idea that would literally change global agriculture forever.
Up until then, farmers mostly used flood irrigation. That method wastes huge volumes of water through surface evaporation and runoff. Blas, along with his son, developed a completely different system: drip irrigation. By using friction inside long plastic emitters, they managed to slow the water down, delivering it in precise, slow drops directly to the plant's root zone. They teamed up with Kibbutz Hatzarim to form a company called Netafim, and they proved this new method could cut agricultural water use by a staggering 50 to 70%.
This brilliant scientific approach to soil water management was then championed globally by Dr. Daniel Hillel. His pioneering work optimized the soil-water balance for dryland farming, and he helped scale this micro-solution to over 6 million hectares worldwide to combat desertification. His achievements actually earned him the World Food Prize, and remarkably, his collaborative research built such strong bridges across borders that his nomination was supported by prominent scientists from several Arab countries.
Now we enter our fourth era, drinking the sea, or the unlimited era.
You see, even with ultimate efficiency, you just can't outrun the climate.
Between 1998 and 2002, the region was hit by its worst drought in 900 years. So, what was the solution? They had to look to the ocean. They utilized an incredibly precise molecular bouncer called reverse osmosis. Essentially, this process forces seawater under extreme pressure through semi-permeable membranes. The pores in these membranes are so unimaginably small that salt, minerals, and trace chemicals get trapped, letting only pure fresh water molecules pass through. But to make this financially viable on a massive scale, they had to innovate. At the Sorek desalination plant, engineers needed to cut costs and dramatically reduce the physical footprint of the facility. So they packed over 50,000 vertical membranes into compact 16-inch pressure vessels. This environmentally friendly, space-saving design set a massive global benchmark for efficiency, and it's a design that's now being copied everywhere.
To really put this into perspective, just think about the staggering numbers from the newer Sorek 2 facility. Built for $1.5 billion, it processes 670,000 cubic meters a day. It can literally turn raw seawater into perfect drinking water in just 40 minutes, leading to an annual output of nearly 53 billion gallons. The resulting water is actually so pure that engineers have to add small amounts of calcium and magnesium back into it just to restore its natural taste and balance.
The result of all this? The technology is now so powerful that desalination reliably provides between 70 to 80% of the nation's entire municipal water needs. Thanks to massive plants like Sorek, residents enjoy a regular, constant supply of clean, fresh water piped directly into their homes, effectively neutralizing the everyday threat of a drought. I mean, think about the tap water you used this morning to brush your teeth. In Israel, there's a huge chance that water was pulled straight from the sea.
Which leads us to our fifth and final section, a global blueprint. Moving from stressed to secure.
They finally transitioned from mere survival to a state of absolute water security. Because of these combined technologies, the massive piping of the national carrier, the extreme efficiency of drip irrigation, and the limitless supply of seawater desalination, agricultural productivity has skyrocketed by an unbelievable 1,600% since 1950. And the craziest part? They've achieved all of this without tapping into any additional natural water resources.
This success story serves as a really critical global bellwether. Regions that are facing severe drought, like the American Southwest, as well as growing middle-income nations like Brazil, are looking closely at this exact blueprint. By aggressively utilizing treated wastewater for agriculture and deploying smart desalination, this model proves that robust policy and cutting-edge technology can actually beat climate scarcity.
Which leaves us with one really critical question to think about. As the world rapidly dries up, as populations boom and climate shift, will the rest of the globe adapt these incredible solutions in time? Can we too learn to drink the sea and tame our own deserts before it's too late? It's a massive challenge for sure, but the blueprint is already out there.